And welcome back to Flexible Games, FortressCraft Evolved modding tutorial. Well, it's time to get a little nitty-gritty, detail, advanced look at things here. I'm going to use the nuclear reactor block itself, which is probably one of the most complex systems out there. I'm not going to say it is the most complex because there are quite a few pretty intricate mods out there. But this one is a doozy. So we have all of our multi-block stuff in here. We've covered that all before. We have all of our placement types and values. All of this stuff we've seen before. And so a lot of it, the multi-block stuff especially, was copied and pasted. However, I started with the laboratory block itself. Copied and pasted the laboratory, and then wound up basically scrapping the whole thing. The multi-block system for the laboratory was very, very old and pretty much all hard-coded and very hard to sort of generalize and compare with all of the other multi-blocks out there. So I basically started from scratch when it came from that. So I was copying and pasting some of the code from like the centrifuge and then modifying these values. So making sure it's still 3x3x3. All of that kind of good stuff is good to go. Now we need to look at the implementation of this mod. So here's the gameplay implementation, all of the different variables involved. So I have a new config. I pass it this value right here in the constructor, and then I start all of the values that is relevant to this. I do hard code the transfer rate, but I hard coded it to 1,000,000 power per second. So we are able to dump obscene amounts of power into whatever block is next to us. Basically, this would take 5 seconds to drain the entire power storage that ships with the reactor. So on that front, I'm not worried about that being too low. 1,000,000 power per second is a pretty obscene amount of power. So let's move on to the reactor constructor itself. So I set the variables. I look at anytime you see these MBMs, this is multi-block stuff. So is center, all of this is multi-block stuff. If we are not the center, we don't care. Only the center links up all of the other blocks, making sure that only the center controls the whole process. And then I go through and I set, based on my config file, I set all of the variables appropriately. And you can take a look and try to follow along what I did here. Meltdown time is the config meltdown timer. Current meltdown timer, I set it at meltdown time because we're counting down from the max. So the current timer starts at the max, which is pulled from the config file. The reactor can explode is a Boolean, which is a true false, which pulls from the Boolean in the config. The power gen is pulled from the config as the power per second. Storage, same. Is melting down, I initialize it as false. Initialize the current power per second at 0. Entity version, very important for reading and writing. And be warned player is something I will get to in a second. Here's all the multi-block code. I am not going to cover all this code. Some of it is very hard to follow, but it all works. So you can copy all this multi-block code, copy this section here from whatever class you want using the IL spy trick I showed in the last episode, and basically set your X, Y's, and Z's to whatever you need, and all of the other values are derived from those. So everything is pretty much set. The only thing that you need to worry about is inside this multi-block, there are functions that use objects. So you just need to make sure that these are set to your object. And usually it will give you warnings or errors or something on those lines. But just make sure to go through and make sure that there's not any weirdness going on there. A lot of these other things I've covered in the past, the spawn game object, making sure that the spawnable object is the laboratory. So that works out quite well. The deconstruct, this is similar multi-block. I don't know why it's not in the multi-block region, but everything else is good. Unity update, we've covered. This is this linked to go is actually the linked to game object. So Unity, everything is basically a game object, and we need to link to that game object in order to run this script. Otherwise, it's just a nothing in the world. It's just sitting there, and there's nothing to process it. So we actually need this script, this code, to link to that 3D game object. And that game object can have many different components. This one happens to have a laboratory base. I'm sure there are more. I have to talk to the developer and see if there's a rotation script on this for the little thing that's rotating inside of the laboratory. I kind of want to tweak with that a little bit, depending on if it is melting down or overheating or not. I spin that up really fast if it's melting down. So here's the normalized power. This just affects the glow of the lab. So as it fills up with power, it'll glow brighter and brighter. So here's our low frequency update. This is called 5 times per second. And here we go. We are detecting whether we're the center. And if we are, we need the Unity update. And here's the MBM state that we need to link or deconstruct. And if we're the server, look for machines. If we're the server, transfer power. And then we go through, if current power is less than the max power, generate some power. Else, current power per second equals 0. So if we are full, if current power is equal to this, we're not generating any power. So we're not even calling this function. So our power per second is at 0. So let's jump into update generating. Now, update generating checks if we have current time. So if we have current time active, if this is greater than 0, then we have fuel left to burn. So update overheating and then generate some power. So let's jump down to update overheating. This is a more complex because it has a few things that it has to do. So this just double checks to make sure we have time, just as a check. So we're active and we come in here. Oh, video just got done. We come in here and we check to see if we have coolant. So if coolant is greater than 0, that means we have coolant. That jumps us down to this line, which then subtracts the current time from the low frequency thread previous update timestamp. This is important. Anytime you're dealing with time in the game, because you're running this code 5 times per second, this time step can change very, very slightly. So we might start with 60 seconds, and this might be 0.2. So it'll subtract 60 minus 0.2, and that'll give us the new time. However, if we are less than or equal to 0, which means we've run out of coolant, we make sure the coolant time is 0. If we're less, we want to make sure it's zeroed out. We want to flag the is melting down. Now we want to check, do we have coolant? So I want to find some coolant. This processes all the hoppers that we have access to and sees if any of them have coolant. If they do, it returns true. So true goes through and says, okay, there is coolant available, so let's try to remove it. And this freeze-on ID, you saw at the very top, this is the ID of the freeze-on. And if it's successful in removing it, this returns true. So we are successful. Therefore, the meltdown timer can equal the regular timer. The coolant time can equal the regular timer for coolant and processing. And we want to set melting down to false and warned player to false. This will come into play in the next section. So if we're melting down, so we set melting down to true here. If we go through all of this and it's still true, that means we didn't find any coolant. We come down here. If we're melting down, yes. So if it can explode, this is the hook that shows the config option for those cheaters out there. If they don't want their reactor to explode, this just returns out and it doesn't do anything. The warned player flag says the first time we enter this, I want to throw a chat up that says a reactor is overheating. You have this many seconds. And I set that flag to true so it's not ever called again. Otherwise, it would pop up 5 times per second for 60 seconds. So I flag that, drop it out. We come in here, we subtract the update timestamp from the meltdown timer. And then we check, is that timer less than or equal to 0? Which means we have run out of time. I actually want to put an F on there to indicate that that's a float. So we have run out of time on our meltdown. So do local chat, a reactor just exploded, and we want to explode. And explode is a very simple procedure that just carves out a huge area of ground, and it's the same code that a chargeable explosive uses. I just have to figure out if there's a way that I can play a sound or what I can do about that. I'm still not sure how I can get that working. I'm gonna have to talk to the developer and see if there's an easy way to do that. But it carves out a very sizable explosion, radius of 40 blocks it will carve out. So that is the update overheating. So we jump back in here and we go to generate power. So let's jump down to generate power. And so I calculate what our power per second should be based on if we're cooling. If we're not cooling, then we double the power gen. So if we're not cooling, times it by 2. If we're not, make it normal. Set our current power per second, and this is for the UI, to the delta, which is what we calculated up here. And then we want to alter it to comply with the timestamp. So we take the value and we multiply it by the timestamp, which adjusts the power output according to how much time has passed. Again, this should be about 1/5 of a second. So it'll be 1/5 of a second of power, which is just 1/5 of our total, which is fine. Current power plus equals delta. So we add the power to the block itself. The game manager power generated. This tells the game we just generated this much power, which affects your threat level, pretty much standard threat level there. Without this command, the game would not know that you just generated power. So then we check if current power is greater than power storage, just set the power storage, just set it to max. Otherwise, the block itself by default stores 5 million power. And with this, you could have 5,005,000 or something. And this just normalizes the amount of power. And then we decrement the time active from the timestamp, and that continues the countdown of how much fuel we use. So let's come back up here and we look at, okay, if we're out of fuel, so if our current time active is less than or equal to 0, we bomb into this else statement. So our current power per second is obviously 0 because we're not producing any power. So we set the reactive time to 0, so it just makes sure it's not, negative 0.2 seconds or something. It's just 0. Then we looked, same way we did with coolant. We check to see if there's a fuel rod around. If there is, check to see if we can get it. So if this grabs it from the hopper, if we did grab one, then set the time active to equal the regular configured active time. This is a debug log because this should never come in here. This got fuel should never be false. If it is, I want to print something out that says, for some reason we found it, but we couldn't get any, because this already checks to see if the hopper is, remove only or add and remove. So this just checks, it's just a double check to see that in the frame that this was called in, if you just happen to remove a hopper at the very second that this goes through, this will cancel out. But that would be a very, very hard thing to do. So we come back up here. That's done with update generating, which is right there. And then we say, okay, we are done with this update. So that's the 1/5 of a second that this is all called. This is all called and run in a 1/5 of a second. And it's called over and over and over and over. And I wish I could get rid of that. So this is all called over and over and over every 1/5 of a second. So the other items that I have in here, the other helper functions. So here's the find fuel rod. Here's the remove function. I pass it the ID number, and here's the ID right here. And it returns true if it's successful. It returns false if it isn't. Or it returns false if we don't have any hoppers. Here's the find coolant. I could combine the find coolant and the find fuel rod into one pretty easily. Just generalize, pass in the ID that I want, generalize this, and use the ID right there. So if I wanted to do that, I could do find item int item ID like that, find item ID. Now this will find any item that I pass into it, but we have to fix now where we call that from. So let's go up to here. So this find coolant needs to be find item, and we need to pass it the freeze on ID. So this will be the same setup. Now we need to look at this, which is fuel found. So we need to do find item, and this is fuel rod ID. And those IDs are up on the top. Here's the freeze on ID, and I have really no idea how to get that ID without just hard coding it. And here's the fuel rod ID, which is my mod mapping. So that is my mod items by key, and there's my key for my fuel rod. So that just generalized the searching of items. It was a quick little change. So I no longer need this find fuel rod anymore. I can just delete it and see if my error list is updated with errors. It is not. I don't have any errors. So that worked great. Remove from hopper already does that item. It already parses through all the hoppers, grabs the first item that it finds. So that is the generalized find item. So it parses through all the hoppers and grabs it. Transfer power. Here is the awesome transfer power. This is what moves the power from the reactor to whatever is attached to it. So if the current power is greater than 0, then we continue. Otherwise, we just return out of this because we don't have any power to give. So this attached PCI stands for Power Consumer Interface. Anything around that has that interface, we want. we want to connect to. So every battery, every face that's touching a battery, everything gets a PCI. And this pretty standard code transfers the power based on current power, the delivery rate, transfer rate, and the capacity of our target power consumer interface. So our transfer rate is fine. We have plenty of transfer rate, but the delivery rate is dictated by the interface. So this just grabs all the PCIs. And then we get into the read and write. Now, this is where your ID version comes into play, because if I went in and later changed this and added something to the save, I'd want to capture the ID version, because the number of writes that you have to equal precisely the number of reads that you have. Otherwise, you will corrupt the segments that the block is in and corrupt them to basically be unrecoverable, because the game has more or less data than it expects. So these two objects, these two calls, are overrides because we get them from our machine entity, and these are called when it's saving to disk or saving to a network as well. It's also can be used for network saving. So as I have the return should network update, I have that, and so it kind of knows to use. If it's pretty basic, it will use read and write for network stuff. So these two are very essential, that you want to make sure you're reading and writing from the exact same amount of data. So the first thing I write is I am the center. If I'm the center, that way I can return and not do any of this code. So the first thing it reads is the Boolean if it's center. If it is center, then I can continue reading just like I have up here. And the entity version is what I would use. So I could do if m entity version equals 1. Why did that? If, there we go. Then I can set, okay, do this code if it's 1. Else if m entity version equals 2. If I release a second version, that's where I would put in the new reader code, but the write is always updated. The write will always be updated with whatever's current. So you can just add lines to the write, but you have to make sure to keep track of your entity version, because things can go very, very wrong if you don't. So right now we are still at entity version 1. So I don't need any of this extra code mucking up my calls. And this will return the entity version. Should network update return true. And HoloBase is pretty straightforward. It creates a new little HoloBase icon with the scale of 333, because this block is a 3x3x3, and it sets the color to yellow. And then it just returns the object here, because this is an override. It returns a call to the HoloBase entity. So that is the reactor in all of its glory and all of its custom code. And I had a fun time programming it. Again, if you want details, if you want, help on a specific item or block, I do read the comments. Leave a comment. If you want specific programming help, feel free to join the Discord. Link is in the description. And, I'm on there. My name is Buggy, and you're welcome to ask questions on the Discord. Lots of helpful people in there, and we have pretty relaxed time. So that will do it for this episode. Look for the mod on the Steam Workshop. if you want to go. The next episode will feature all of the blocks and all of the glory in game. So you'll see what everything looks like. Again, thank you for watching, and I will see you next time.